Welcome back to another video regarding the Windows authentication process. Last time, what we did was we covered the local user account. Today, we are going to cover the domain user account. To be honest, after the local user account, I didn't want to create another video for the domain user account. But recently, I have seen that in the last video, people have started asking questions for the second part. And that means there is a requirement for this one. So I thought, why not just go ahead and let's create one. And this is for you guys. So the way this video is, I did this video is that I will explain different concepts before jumping into the authentication process. Different concepts will be discussed, and then at the end of the video, we'll gather all those components and try to make sense out of the whole process, that how does this work. So by now you will have a fair idea that when it's a domain user account and the user has to be authenticated on a network from the Active Directory, we are going to use the Kerberos. But let's start with the first one. Part one, Windows Logon process. We already have that on YouTube. And today we are going to discuss Windows Logon process via Active Directory on domain user account. So there are two types of accounts, local account and domain accounts. Local accounts are stored individually on each computer. It could be a laptop, desktop server, anything. As long as it's a Windows machine, the local account is going to be saved on your own machine in this path. For example, C Windows System 32 config SAM. In the SAM, you will have a local user account. The domain account, however, is not stored on your machine. It is stored somewhere in a central repository. For the Windows one, we call it Active Directory or domain controller, and the file would be ntds.dir. Now, the first concept that we discussed was the types of account. One is a user account, local user account, one is a domain user account. The second concept that we are going to discuss is about the encryption. Now, there are two types of encryption. One is symmetric encryption, the other one is asymmetric encryption. The symmetric encryption is a way of encryption where we are going to use only single key to encrypt or decrypt the same information. When we are doing an encryption, what we are going to do is we are actually converting a plain text into a ciphertext so that when it is traveling over the network, nobody can read the ciphertext because it would be encrypted with a key. Only the person who has the key, the secret key, will be able to decrypt it using the same key with which it was encrypted. So, simple baseline is, if during the encryption there was a single key that was used, it would be a symmetric key. Most widely used algorithms will be AES 128, 192, or 256. The challenge around symmetric encryption would be the scalability, but that is not an issue in this case. So we will move ahead with asymmetric encryption. Asymmetric encryption is also called public key cryptography. In the public key cryptography, we have two keys. One is public key, which is known to everybody. One is the secret key, which is known to the only user that is going to encrypt XYZ information. So in the asymmetric encryption, one key is used to encrypt the information. The other key is used to decrypt the information. But both of them, public and private, both of these keys have to be used together to decrypt the information or encrypt. In our case, we will be mostly focusing on the symmetric encryption, where you have the same key. Just a summary: symmetric, you have the same key; asymmetric, you have different keys. Okay. Now, this is the screen that I took from the last presentation, where we discussed that how the logon user interface starts. Secure desktop is given to you, then you have a Windows logon process. For all these details, you can see the first video. But what LSAS process does is that it will see that what kind of user account type is. In this case, it's a domain user account type. It goes to negotiate that what kind of SSP I'm going to use. For the local user account, it used MSV1_0 SSP. But for this one, it is going to use Kerberos. Now, what is Kerberos? Kerberos is basically a secret key based service to provide the authentication in open networks. Why open networks? Open networks because, like, if you have to provide the authentication between your own machines, which are trusted machines, but you can use the Kerberos even when those machines are on the untrusted networks. Why? Because the plain text passwords that you're going to use, any client or a user is going to enter on the terminal a plain text password, but that password is never going to go on the insecure network. It's not going to ever on the wire. So that is why, since the password is not being shared on the wire, it can be used on the untrusted networks as well. It was first developed in the MIT. Still, it's an open source authentication protocol. However, since 2000, Windows has adopted it, and now it's a default authentication protocol and is used in the Active Directory. There are few concepts around Kerberos that are important to understand before we jump into how the domain user account gets authenticated using Kerberos. So the first one that we're going to discuss is KDC. One part of the Kerberos is that the client, which needs to do the authentication. The other part is the services, where, for example, now you are on a network. You're not only going to just authenticate yourself, you are going to use services also. How you want to authenticate is where the KDC comes in. KDC is basically a key distribution center. It is a component in the access control system, which is responsible for servicing the user requests to access the resources on the network. So if my client on the left side wants to access any of the services on the network, be it a printer, be it a file sharing service, be it a database server, it has to authenticate itself using a third party. And in this case, the third party would be KDC. KDC has further three components, for example, authentication server, ticket granting server, and Kerberos database. For now, do not worry about what are these three different components. We will discuss them in detail. Now, implementation of the KDC may differ from any system to system, but the main components will be authentication server, ticket granting server, and Kerberos database. Authentication server issues the tickets, like ticket granting ticket, and ticket granting service is going to issue further access to the services. Kerberos database is where you have all the keys for the different clients present and saved in your database. Authentication server serves as an authentication part of the Kerberos environment. Ticket granting server, it serves as a service ticket provider for the Kerberos environment. Database, it serves as the storage of secret keys of the clients and servers for the Kerberos environment. Maybe these terminologies are confusing right now, but just We will discuss all these one by one. So the first one is the keys. The keys that the Kerberos database has are like user keys, system keys, and service keys. These are the long-term symmetric keys that are derived from the user's password. The plain text password is transformed into a cryptographic key by passing the text of the password through a cryptographic functions. And the result of that cryptographic function would be the long-term key that we are going to call. Now, for a user account, whenever the user is created in an environment, the password that you will give to that user, that password is used to create a user key. Now that user key is going to be saved in the Active Directory. And when I say Active Directory, that means it's going to be saved in the Key Distribution Center, because Key Distribution Center in the Microsoft environment is part of the Active Directory or a domain controller. The same key is generated every time the user or the client logs in to the workstation. Now, this is important. Once the new user is being created on the domain, the password that you are allowing and the password that you are allocating to that user is being used to create the user key. Now, this user key is now saved in the KDC. The same goes for the system accounts. The system joins the domain. System accounts password will be used to create the system key, and that will be saved in the KDC or domain controller or Active Directory. Service keys are based on the account password that they use to log on. So now we have the long-term keys that we generated using a cryptographic function and the password of the user or the system or the service. And now these keys are stored in the KDC, Key Distribution Center. Remember, KDC now has the username and the user keys or the system keys available with it. There's one more concept before we dive in is KRB TGT account. Just like we talked about that when a user is created, the password is used to create the user key. KRB TGT account is a service account for the key distribution center. The account and the password for this account is created when a domain is created in the environment. When you are deploying the Active Directory or the domain controller for the first time and you have created a new domain, the KRBTGT account will be created and the password will be allocated. And the password for this is almost never changed. Why? Because this is a very important account being created on the Active Directory, and importance of this account will be visible when we move forward to understand how the Kerberos works. Service principal name is just a unique identifier for any service instance. For example, the Kerberos itself is a service. It will have its own service principal name. These are used by the Kerberos authentication to associate a service instance with a service login account. Now, before we dive into the Kerberos authentication protocol, let's take a look at this diagram. I understand this diagram is like very basic. However, let's understand and see that the lady on the left side in a pink dress wants to go inside the circle and try to avail all these red, blue, green, and yellow services. However, before she enters and tries to access those services, she has to pass through the gate. And that gate pass is the main pass to enter in any of the circle. And once you are in the circle, then you can go to any of the services and then show them the gate pass that you got. That means that you have been authenticated and you can access those red, blue, or green blocks. Now, this main pass is going to be given to that lady at the start of the authentication. Once she comes to the gate, she will get a pass, and now she can use that particular pass to access any of the services inside. Similar to this is going to happen in the Kerberos. So now we are back to the main point. We have discussed about the different concepts. We discussed about the encryption. We are going to use the symmetric keys. We discussed about the local user account and domain user account. And then we discussed about the Kerberos and the KDCs. And the main thing that we discussed was that the KDCs has the user keys, the long-term user keys, and the usernames as well. Now, once the Kerberos has been selected as the SSP, the next step that happens is something like this. On your left-hand side, you have different users that they want to authenticate themselves from the domain controller and access any of these services. The first thing that the user is going to do is they are going to request the ticket for a user. They will get a ticket, then they will request for because that ticket is for the authentication of themselves. Then they want access another service, they are going to request another ticket, and then they will get the service ticket, and that is where they will take that service ticket and access the service. Now, in the next slide, we're going to use all these concepts that we discussed one by one, and hopefully everything will fall into place and everything will start making sense. Now, the first time the user logs in to the workstation, what happens is, as soon as the user has entered its credentials and logged in, the password it has entered, using that password, a key will be generated. Remember, similar thing happened when the user was created. Now, this key is going to be used to encrypt the current timestamp and a username which already he has given to the system. The username and the current timestamp is encrypted using the user's long-term key and sent to the domain controller. Now, on the right-hand side, remember the domain controller has its own KRB account. It has all the users' passwords, service passwords. So what the domain controller will do is, when the domain controller receives the request from the client who just logged in into its machine, he sees that one, I have a username. Second, I have something encrypted. What it does is it goes into the KDC, matches the identifying username, and extracts the long-term key which is present in the KDC since this user was created, and tries to decrypt that timestamp using that long-term key. Now, if the user on the workstation has entered the right password, that means the right long-term key was generated and the timestamp was encrypted with the right long-term key. Now, on the domain controller, if the domain controller is able to decrypt the timestamp with the long-term key, that means the user entered the right password. If the user did not enter the right password, that means the domain controller will not be able to decrypt using the long-term key. That means the user has not entered the right password and the request will be rejected, and the request will be sent back to the user with login failure. If the timestamp was decrypted using the user's password or the long-term key, Now there are two steps that the domain controller is going to do. The first thing is the TGT, the ticket granting ticket. Ticket granting ticket will be generated by the domain controller and it will be encrypted using the KRB TGT password. Now remember, the KRB TGT password is the main password that was created when the domain was created. Nobody else knows the password for KRB TGT password. KRB TGT account. Now TGT is being encrypted with the long key of the KRB TGT account. Along with that, domain controller is going to create a temporary session key. And the temporary session key is going to be encrypted using the user's password or the user's long-term key. When this reaches the user is going to store that TGT in its local cache, and it can request another TGT whenever this TGT expires, because TGT will have a limited time. It will have a limited time to live. Now, let's talk a little bit about what is this TGT. Remember, the user requested the domain controller for authentication, and now he's getting a TGT from the domain controller. It is a response to the client's authentication service request, and now TGT is basically a service ticket for the domain controller itself, for the Kerberos or the KDC itself. This special service ticket is called a ticket granting ticket, and it enables the authentication service to safely transport the requester's credentials to the ticket granting service. TGT includes user's initial ticket from the authentication service. It is used to request more service tickets and is only meant to be used by the ticket granting service, that is KRB TGT only. Because remember, the TGT is now encrypted with the KRB TGT password that is known only to the domain controller. Nobody else can use this TGT. So the next step would be now when it reaches the TGT encrypted with the KRB TGT password, reaches the user will keep a cache copy with itself. Next, the session key that was shared with the domain by the domain controller, and it has been encrypted with the user's password or the long-term key, this will be decrypted by the user because the user knows the password and it has been encrypted with the same password, so it should be easily decrypted. This session key is important because the session key that was encrypted using the user's password and now the user has decrypted it. Remember that the same session key is also present within the TGT because in the next step, this session key is going to be used for request another service, and the domain controller will have to do the comparison. So I'll just go through one more time from the start so that it is clear. The first request from the user when he logged into the machine was the username and the timestamp encrypted with the user's long-term key or the password. For simplicity, I will just use the password now. It goes to the domain controller. Domain controller identifies the username. Yes, I have the username, I have the long-term key. And for the first time, it takes out the long-term key and uses the long-term key to decrypt the timestamp, checks the timestamp. Yes, the timestamp is fine. And creates a TGT. Within that TGT, the system is going to put the initial authentication service request. It is also going to put the session key, that is a temporary session key, and encrypt that TGT with the KRB TGT password. The session key that is in the TGT is also encrypted using the user's password as a separate entity. Both of these are sent back to the user. Now user has the TGT, which is just a service request, a service ticket, but it is encrypted with the KRB TGT password, which the user does not know, and he cannot do anything with it. The session key, however, is encrypted with the user's password. The user will decrypt that session key and use that session key, which it received from the domain controller, to encrypt the service principal name, the next service that he has to use. And TGT, which is encrypted with the KRB TGT password, will be sent back to the domain controller as is. Now, the only new thing that the domain controller is going to receive is the service name that the user wants to access now. Now, once this reaches to the domain controller will decrypt the TGT using its own password and take out the session key, which it already has a session key, and decrypt the session key, decrypt using the session key the service name, that what service is the user requesting. Once it knows the service principal name, since service principal name is just like a username, it will take out the service long-term key and it will create another temporary new session key. With that new session key, this will be encrypted using the service password, the service account's password. Sorry. So now domain controller is creating a TGS. The first was the ticket granting ticket. Now it is a ticket granting service because it is specifically for a service other than the KRB TGT. Now this ticket granting service will be encrypted using the service account password. Service account password domain controller already knows because when the service was created, the password was allocated to it and the long-term key was created. Now TGS is encrypted with the service account password and the new session key is being encrypted using the user's password. Now this same new session key is also present within the TGS as well. Because remember, this TGS will go to the service server and the service server will compare this new session key to ensure that it is the same user which has been authenticated already by the KRB TGT. Now, when this information, the TGS and the new session key reaches the user now, the TGS is something that user cannot decrypt because it has already been encrypted using the service account password. The new session key, however, is encrypted using the user's password and user is going to decrypt it. It will take out the new session key and it will add whatever authentication service that it wants to send to the service server and encrypt their data with the new session key that has been provided. Now remember, this new session key is already present in the TGS as well, which is encrypted by the service account's password. Now once this data reaches the service server will decrypt the TGS using its own long-term key, which it already knows, and it will take out the new session key from within the TGS. And now it will use that TGS, the new session key that it extracted from the TGS, to decrypt the data request that exactly the user has sent. Now, what's the benefit of this service tickets? We have a TGT, we have a TGS, because the servers, whatever server, either it's a domain controller or any other database server or a file server that uses, it does not have to store the session key that it uses in communicating with clients. It is the client's responsibility to hold a ticket for the server in its credentials cache and present the ticket each time it wants to access the server. For example, one time the domain controller has given the TGS to the user will keep the TGS in its cache, and whenever it wants to access the database server, it will use the same TGS because that TGS has been encrypted using the service account password. And the service server can always decrypt that TGS and use that to authenticate. The client does not need to go back to the KDC each time it wants to access to this particular server. Service tickets can be reused, and to guard against the possibility that someone might steal a copy of a ticket, service tickets have an expiration time that is specified by the KDC in the ticket's data structure. Now, how long it is going to be valid, it only depends on the way it has been structured. And in any case, when the user logs off, all the credentials cache are flushed and all the service tickets as well as the session keys are destroyed. Now imagine why this data that is being encrypted with this new session key is important. Because every time, the target server can trust the contents of the TGS because that is encrypted with the target server's own secret key. However, the target server cannot trust the ticket was really sent by the client, that is, for example, the user. So the reason is that the new session key was created by the KDC. If you remember, the domain controller created that, and it encrypted the user with the user's password. The user decrypted it and got the new session key and used that to decrypt the data and to encrypt the data. The same new session key is also part of the TGS. That is, when the domain controller created the TGS, it puts that new session key within the TGS. Now, when this TGS reaches the service server, which is encrypted by the service account, it will be decrypted using the service account. So the service server can be sure that the TGS is valid because it has been encrypted with my service account. And when it decrypts, it will get the new session key from inside the TGS. Now, service server is going to decrypt the data using the new session key. If the data gets decrypted, that means the user that is sending me the data is a validated user by the domain controller. Now, in this whole setup, we did not send the user's password on the network even for a single minute. All the time from the login, when the user first logged in, the long key has been used. Even though I use the terminology of the user's password in place of the long key, but the user password never went to domain controller or the service server. It has always been the long-term key that has been moving between the different servers. I hope this was understandable, but even if you have any questions, you have any confusions, do let me know and I'll do my best to answer your queries in the comments or in any other way possible. Don't forget to subscribe and like the channel. Thank you so much for your time. Take care.